Mr. K. Balraj is working as a polymer consultant and teaching fellow in the area of polymer science and engineering at CEG Anna University, Chennai. He has completed AMIE in electrical engineering at the Institution of Engineers India, Calcutta, and MTech Polymer Science and Engineering at CEG Anna University. He is also pursuing his doctoral research work in polymer technology. His area of specialization includes polymer rheology, polymer processing, characterization and testing of polymers, polymer blends and composites, and insulation technology. He has in-depth experience on plastic properties, testing methods, and the relevant standards. He has more than 15 years of teaching experience in polymer science and engineering, including instrumentation in polymer industries, engineering plastics, conducting polymers, and rubber technology at CEG Anna University. He has guided more than 30 MTech students in their research projects. He has presented more than 20 research papers in the national and international conferences in the area of polymer science. He has published 10 research papers in the peer-reviewed journals.
Welcome to UGC lecture series in polymer science. In polymer science, the course is polymer processing and mold design. This is the 8th part. In today's class, we will discuss about the different types of ejector system. Before that, what is a ejector system? It consists of ejector grid and ejector plate assembly. We will see in detail about that, and then the different ejection techniques which is normally used in injection molding, and then ejection from fixed off and ejection of sprue pullers, and how to do the molding process with respect to parts that involves undercuts. First, the ejector system. The ejector system or ejection system, both are one and the same. This is the system which actually facilitates the positive ejection of the molding after it solidifies, is what we call it as ejection system. That is, once the molten resin fills the cavity, when it is allowed to cool, it will solidify. Once it is solidified, the product is ejected out. That is what the system which does this is what we call it as ejection system. The ejection system can be activated automatically and can be mounted behind the moving off. So, normally this ejection system goes with the moving off. Any mold will have two offs, one is fixed off and another one is moving off. So, to this moving off, the ejector system is fixed. Now, the ejector system consists of ejector grid, ejector plate assembly, and then it also accounts for the different methods by which the ejection is actually carried out. First, we will see what is meant by ejector grid. So, the ejector grid basically consists of a back plate and support block. So, normally there will be two support blocks, rectangular support blocks that are placed on top and bottom of a back plate, and also it provides space for ejector plate assembly. In between these two support blocks, the ejector plate assembly would fit in. Now, the ejector grid is the part of ejection system which actually supports the mold plate. Now, there are three types of ejector grid. One is inline ejector grid, frame type ejector grid, and then circular support block grid. So, in all these the construction varies. So, the inline as the name indicates, the injection of the resin into the cavity as well as the ejection all will be in one line. It all will be in one plane. So, in the frame type it is in a single frame, and then in the circular support block grid, the support blocks are placed in a circular way. First, we will see what is meant by inline ejector grid. It consists of two rectangular support blocks mounted on the back plate. Now, the ejector plate assembly is mounted in between these two support blocks. Now, this type of design is suitable for small molds where space available is less. Extra support blocks may be added to support the mold plate, because the mold plate has to be strengthened sufficiently in order that it does not get distorted due to the high injection force, because the resin is injected at a high pressure from the nozzle to the mold. Therefore, this mold plate should not get distorted in the sense its position should not be altered. In the circular support pillar grid, the circular it consists of support pillars in the circular fashion mounted on the back plates. The grid is attached to the mold plate by socket headed screws. So, therefore, socket and screw arrangement is provided. the ejector plate assembly can move freely in these support pillars. They can move, the ejector plate would normally move when the mold opens, the ejector plate would also move. This type of grid is used for large molds, unlike the inline grid mold, which is meant for small sized products. This circular support pillar grid system is used for large molds to prepare a large sized product. Now, next the ejector plate assembly. The ejector plate assembly consists of an ejector plate, a retaining plate and an ejector rod. So, this ejector rod is going to finally eject the product out, and then this ejector plate moves first, followed by the ejector rod, and then the retaining plate will ensure that the ejector plate, once the product is ejected out, the ejector plate assembly would have to restore its original position, which is done by this retaining plate. Now, the ejector plate assembly is that part of the mold to which the ejector element is attached, which is the ejector rod. Now, the assembly is contained in a pocket formed by the ejector grid. So, that is in the ejector grid we have seen that there is a space in between the two support blocks, which forms a pocket like arrangement. That is where this ejector plate assembly is going to fit in, and then it is directly behind the mold plate. Now, one end of an ejector rod is threaded and it is screwed into an ejector plate. In this particular design, the ejector rod functions not only as an activating member, but also method of guiding the assembly. That is, normally the ejector rod is threaded and screwed into the ejector plate in such a way it not only ejects the product out, it also guides the ejector plate assembly to come back to its original position. Here the parallel portion of the ejector rod passes through an ejector rod bush. This ejector rod is going to move that is around this ejector rod, a ejector rod bush is provided. So, that will ensure that the ejector rod moves smoothly, and then this ejector rod bush is fitted in the back plate of the mold. So, the diagram shows a complete ejector system. First the ejector grid, which consists of a black plate followed by two support rectangular blocks, and in the space between this is the pocket like arrangement. So, this is where the ejector plate assembly is going to fit in. The ejector plate assembly is this. So, once the mold is closed, this ejector plate assembly will just get completely fitted inside this region. Now, if you look into the ejector plate assembly, it has an ejector rod which is going to actually tip the product out, and then this is the retaining plate which will pull back this ejector plate once the product is ejected out, and then this is the ejector plate which actually moves the ejector plate assembly forward. Now, we will see in detail about the ejector plate, which is the main part of an ejector plate assembly. An ejector plate moves an ejector pin which is going to actually eject the part out. A push rod is pushed out of the molding machine to eject the ejector plate. So, normally the ejector plate moves along with the motion, either with the open or closed movement of the mold. Once it is opened, then a push rod will push this ejector plate assembly or the ejector plate, which is going to push the ejector pin to eject the part out. Now, you have a return pin also that is provided in the ejector plate assembly. This is normally used to return the ejector plate to its original position. So, with this method, the edge of the return pin touches the surface of the cavity plate. We will see what is the cavity plate. So, in any mold you have one core plate and a cavity plate. Cavity plate is normally provided on the top and the core plate on the bottom. So, the edge of the return pin touches the surface of the cavity plate during mold closing and pushes back the ejector plate, but molding cycle due to this design would look as though the molding cycle takes a longer time to complete, but then a small mold often uses a return spring to return the ejector plate before mold closing after completing the part ejection, which can help in reducing the cycle time, that is the molding cycle or the cycle time for a mold. Now, this is a ejector plate diagram in which you could see this is the cavity adapter plate, or this is the cavity plate and this is the core plate. So, in the cavity plate is where we have the nozzle. This is the region from the cavity plate side. The resin is going to be injected, and then the core plate supports this ejector plate. The ejector plate, you have one top upper side and lower side, and this is the ejector pin. Now, once the core plate is going to open or close, this will in fact will move this ejector plate. As a result, because of the movement of this ejector plate, this ejector pin will move up. This is actually the product. So, this will push or tip the product out. Once the molding is over, this return pin which touches the surface of this cavity plate will ensure that the ejector plate comes back to its original position once the core plate is going to move down. And then these are the different guide pins that are threaded in the molding system, which will ensure that all the given parts are going to move in a particular way. Now, next the return pin. A return pin is used to avoid damage to a mold by colliding with the parting line surface. So, parting line is nothing but the line where the product is normally ejected out. So, therefore, this return pin would be provided in such a way that will just touches this parting line surface, thereby pushing down an ejector plate to return an ejector pin to the original position. If the to the original position when a mold is closed, this will be clear in this diagram. This diagram you could see this is the ejector plate, and this is the core plate, and this is the cavity plate, and these are all the ejector pins. Sometimes you go for multiple ejector pins. That all depends on the type of product that is being formed. Normally, one ejector pin itself is enough if the product is of thin shape. Now, this is the return pin. Once the mold closes, this return pin will ensure that this ejector plate moves down, and also the return pin, the ejector pin would also move down. If the ejector pin and the ejector plates are not going to move down, then once the cavity plate closes the core plate, then this is going to damage this mold. So, in order to prevent this, the return pins are normally provided in any molding system. Next, ejector techniques. When a molding cools, it contracts by an amount that again depends on the material being processed. That is the type of material, whether thermoplastic material or a type of polymeric material. Now, for a molding which has no internal form, that means there is no intricate design inside the product. Then, for example, consider a solid block, either a rectangular block or a square block. Now, the molding will shrink away from the cavity walls, because once it cools or once it gets solidified, there will be reduction in size. Therefore, naturally the product that is being formed is not going to touch the surface of the cavity walls. Therefore, a simple ejection technique could be used there to eject the product out. However, when the molding has an internal form, some curved shapes on the surface, then as the molding as it cools, this will shrink onto the core itself. Wherever incomplete portions on surface of the product, this in fact will tend to adhere to the core. So, therefore, a simple positive type ejection would not be sufficient there. There are several ejection techniques to choose from, but in general the choice will be restricted to the shape of the molding, that is again the shape of the product. Now, there are a number of ejection techniques, but these are the basic ejection techniques: using a pin or using a sleeve or using a stripper plate when the product is of bigger size, and then apart from this, compressed air is also used to eject the product out. We will see one by one. So, in the pin ejection, these are the ejection pins. The position of this pin, the position of these pins is that is normally where the release resistance is high, that is where it is provided. If the resistance is same, it could be positioned evenly, that is release resistance is very high here, then the ejection pin is provided like this, or otherwise the ejection pins could be provided here and here alone. Here you could see there is ejection pin which touches the top of the product, another ejection pin at the bottom of this bottom end of the another product. So, therefore, the positioning of this pin type ejection depends on the release resistance offered by the product. Now, once the ejector plate moves, this ejector pin will move upward, and then this will tip out the part or the product from the female half of this mold. Next one is sleeve ejection. So, sleeve ejection, the processing is simple and easy. However, the type with a sleeve inner diameter either too short or long is difficult to process, whereas a thin type is likely to crack in use. So, even though processing is easy, there are some drawbacks with respect to the diameter of this sleeve. But on the other hand, if you look into the advantages, the release is made properly as it ejects evenly with the edge. So, we will see that. So, this is a sleeve type ejection where this ejection pin is surrounded by a sleeve like arrangement, which will ensure that this is the part that is going to be ejected. Now, here the part is subjected to ejective force on all these regions. So, therefore, as it moves up, so it evenly pushes the part out. So, that is the advantage with this sleeve type ejection. Next, the stripper plate ejection. As a stripper plate ejection has an advantage of an wide ejecting area compared with the others. So, reliable removal is achieved even if ejecting resistance is high. Some of the polymeric melts will tend to adhere to the core or to the mold cavity. So, thereby the release resistance would be very high for such products. Therefore, in such cases one should go for a stripper plate ejection. At the same time, the appearance is better since no ejection trace is left. So, in the pin type ejection, contour would sometimes would get transferred onto the product. So, therefore, that trace would be there, but then in the stripper plate no such ejection trace would be there. So, this is a typical diagram showing the stripper plate ejection method. So, this is the female part of this mold and this is the stripper plate. The stripper plate moves up and then it you could see it is in contact with the more surface area of this part, and then this part is ejected out. Next, the compressed air ejection. Compressed air ejection is often used to support the ejection of parts with a deep container, that is parts with more depth and also round shaped parts, or to support stripper plate ejection to eject parts smoothly from a mold. It is not it is used alone, or it is also used in along with stripper plate ejection to eject the part out. This is because it effectively avoids generating a vacuum. In the stripper plate method, as the stripper plate tips the product out, there is a vacuum area that is formed between the mold core and the part, and also this vacuum is going to have an effect on the final quality of the product. And also, unlike pin ejection, in this method removal by even pressure does not cause such defects as cracking or whitening to parts nor deformation. These are the typical defects that is normally found in pin type ejection, and also even to a part with low deflection temperature and load. So, this is a typical scheme of compressed air ejection where it is used in along with the stripper plate. So, this is the stripper plate. As this stripper plate moves up, then there is a vacuum that is formed between this part as well as this mold. So, there the compressed air moves, and then thereby preventing the vacuum between this part as well as this mold. So, now once the stripper plate moves up, the compressed air valve is also opened, and then therefore, this compressed air would also push the part out. And then the next type of ejector techniques is called as two-stage ejection. But then this method normally involves 2 steps in ejection of parts. It consists of a stripper plate as well as pin ejection. The procedure starts with first the stripper plate ejection to eject an entire part, and then it is finished with pin ejection to eject such areas as boss or undercut. We will see what is an undercut or a boss. These are the intricate design with respect to the product, and then it does not cause warpage. Warpage is the reduction of the mechanical properties due to improper molding, and then deformation or cracking to part. So, this is a typical 2-stage ejection scheme. where first the ejector plate moves the part up, and finally here you could, this is what is an undercut. Now the part that is just adhering to this would not be now as the ejector plate moves up, the part will not remove easily with respect to this region as well as this region. Now once the ejector plate moves the part out, next the ejection pin would again push the part out, thereby reducing the release resistance that is being offered here as well as here. Now ejector from fixed off. So far we have seen ejection system that is normally provided in the moving off. As we have seen earlier, a mold will have a fixed part as well as a moving part. To the fixed part is where we have the nozzle and the resin injection system, and then to the moving part is where we have the core. Now we will see what happens when the ejection system is provided in the fixed off. While it is generally desirable to situate the ejector system in the moving off of the mold, but then in some cases because based on the product shape, this is not always practicable. Now for example, let us consider a box type component which must for reasons of appearance, that is some of the products there should not be any surface irregularities that is tolerable. So in such cases the gates are provided inside the box. In this case the core and the ejector system have to be compulsorily mounted on the fixed off of the mold. Now if you do that, there will be two main complications. Firstly, to incorporate an ejector grid and ejector assembly behind the fixed mold plate, this makes this mold to be excessively deep. Normally when you design a mold, the fixed off and the moving off would be of uniform dimensions with respect to the shape, whereas once we want to incorporate this ejector grid and ejector plate assembly in the fixed plate, this will make this fixed part of the mold to be excessively deep. So because of this, the melt has to travel a long distance from the machine's nozzle, but however this distance can be minimized by arranging a sprue bush that runs deep into the mold plate assembly. Secondly, now facilities are not normally provided on the machine for activating any type of ejector system that is going to be fixed on the fixed off of the mold side. So this is another drawback once we want to have a ejector in the fixed off. So this means that a separate activating mechanism must be incorporated in the mold design apart from the activating mechanism that is provided in the moving off. Next sprue pullers. Earlier in the when we discussed about the feed system, the feed system consists of sprue followed by runner and gate. Now once the product is ejected out, both the sprue, runner and as well as the gate are going to be trimmed out. In some of the cases the sprue could not be removed as easily, that is what we mean by sprue pullers. Then we need to make some arrangement that will remove the sprue out of the mold. When the mold opens, it is essential that the sprue also pulled out positively from the sprue bush. For single impression molds, the sprue fits directly into the base of the component. The sprue is pulled at the same time as the molding is pulled from the cavity. That is, the ejection system will act in such a way, once the product is ejected, it also ejects the sprue, runner and gate. For multi-impression molds using a basic feed system, the sprue would probably be left in the sprue bush each time the mold was opened. So for a single impression system, the sprue is going to rest on the surface of the part. So therefore as the part is ejected out, the sprue would also be ejected out, whereas in multi impression molds the sprue would be left in the sprue bush itself. So therefore this will require a manual operation to remove this unwanted sprue every time for every molding cycle. To avoid this undesirable feature, an arrangement for pulling the sprue should always be incorporated in the design. That is what we mean by sprue pullers. The common sprue pulling methods utilize an undercut pin or an undercut recess situated directly opposite the sprue entry. Now the plastic material which flows into the undercut upon solidifying, because it is going to cool, as a result it will solidify. Now this will provide sufficient adhesion to pull the sprue as the mold is opened, because the resin is going to solidify, and then the solidified resin along with the part will be pulled out. Now, there are two basic design for sprue puller. In one, the undercut is produced within the cold slug well region and is situated below the parting surface. Now, the cold slug well region we have seen earlier when we discussed about the runner. So, the cold slug well region is is normally provided in a mold to facilitate that the resin which of appropriate temperature is going to fill the mold cavity. Now, in the other design, the undercut portion of the sprue pulling device is situated above the parting surface. Now, next we will move on to the undercut process, the how to prepare molding of parts that is going to have undercuts. Now, what is undercut? Undercut refers to the convex or concave area of a part. That is, if the part is not of any square or rectangular cross section, the part involves a curved portion. That means that one has to adopt a method suitable for preparing such part. When removing the part from the mold, you need some device so that the part of the mold which contacts to the undercut can be moved to remove the part from the mold, since the part will not be removed directly without the device. So, if it is of a square or rectangular dimension, it is going to shrink out. As a result, it can be easily rejected out. Now, whereas if it is going to have convex or concave area, the region in between the region below this convex or concave area of the part will not be removed easily. Now, this process is what we call it as undercut process. So, these are the examples of parts with undercut. For example, a push pin, what we normally use in the table to fix a paper. So, this region represents the undercut. So, this is not of uniform circular cross section. Now, it has 3 different cross sections. So, this region is undercut. Again, the screwdriver, this region refers to a undercut. So, these are the regions where the release resistance would be high. So, as a result, the project could not, the part or this product would not be ejected out easily. Similarly, coffee cup, where this handle region, this region refers to undercut. Now, the mold that is going to be in contact with this region would offer more resistance for this cup to be removed out. Now, undercut process uses different methods depending on whether the undercut is outside or inside the part. So, therefore, removal of such parts, the type of method what we are going to adopt basically depends whether the undercut is either inside the part or whether it is going to outside the part. But then there are the 3 methods: external slide core method, which is basically meant for a part with outer undercuts, and internal slide method for parts that has internal undercuts, and then sometimes hydraulic cylinder method is used, which is irrespective of the undercut, whether it is present in the internal side or on the external side of the product. Now, we will see what is an external slide core method. The external slide core, as the name itself implies, there will be a core that can slide. So, that can slide, that is it can move either behind or either it can move horizontally or vertically, and this is normally usually used for the process of outer undercut. This external slide core will normally work along with the open and close movement of a mold. That is, this method involves sliding this slide core to process the undercut. So, this is an external slide core method. Now, it consists of locking block, which will ensure that angular pin is provided, and now this is the part and this is the undercut region. So, because of this undercut, once you tip this product out, this portion would not release out. So, therefore, one need a method like this, and this is basically the slide core, and then this is a pushback spring. This will ensure that the slide core can move forward or it can move behind, and then this core stop block will again function in such a way according to the mold, whether the mold is going to open or the mold is going to close down. This has to stop this block, and this is the cross sectional view and this is the side view of a slide core. Now, the larger the undercut becomes, the longer an angular pin needs to be, and more the movement of the slide core will be. Therefore, it may not be easily used. The slide core moves to avoid retreating by injection pressure at the locking block. So, the locking block would prevent the retreat of the slide core when it is subjected to high injection pressure when closing the mold, and at the core stop block when opening the mold. So, the locking block and the core stop block function depends on whether the mold is closed or whether the mold is opened. In between them, an angular pin will actually controls the movement of this slide core. Now, the locking block which is installed to the cavity plate, we have seen what is a cavity plate, which is normally the plate on the top of the mold system, that is where the resin is injected. Now, this will receive the pressure from the injection when closing the mold. Once the mold is closed, that means that the plastic resin is going to be injected into the mold cavity. So, therefore, this locking block is going to be directly exposed to this high pressure. Upon opening of the mold, the slide core moves backward by the force from the angular pin and the pushback spring that is provided, thereby releasing the part more easily. Now, this is the typical external slide core diagram. Now, this is the part with an undercut. This is the locking block, and this is the slide core. So, this once the mold is going to open, then this the locking block is going to move back. So, as a result, the slide core is no longer locked, it is free to move down. As a result, the product will be ejected out more easily. To summarize, in today's class we have discussed about what is an ejector system, which basically consists of a ejector grid and ejector plate assembly, and then the type of ejection techniques, a pin type or sleeve type, or a stripper plate type, or a compressed air type. And then what happens when we want to have this ejection system in the fixed off, because normal ejection system, the ejecting mechanism or the activating mechanism are provided in the moving off. Now, what happens when it is going to be provided in the fixed off and the resulting complications, but then for some of the products one has to necessarily go for ejecting the product out from the fixed off side, and then how to remove the sprue. In some of the cases, the sprue, particularly in the multi impression molds, the sprue will be left behind the sprue bush. So, therefore, sprue pullers would ensure that the sprue would also has been pulled out. And then what is an undercut, and how to design a molding process to process this undercut or to remove the products that has an undercut. Now, after looking into this episode, these are the questions the readers, the viewers should try to answer. What is an ejection system? State the different types of ejector grid. Describe the functions of a ejector pin and return pin in ejector plate assembly. So, this ejector pin and return pin are the two main pins that actually moves this ejector plate in such a way whether to eject the part out. List down the basic ejection techniques in the ejection system and what are undercuts. Thank you.